In this tips and tricks video, we're going to look at cut quality. Basically, once you've prepped your space, you've got appropriate lighting, you've got your tape aligned correctly, you've scanned, you've installed a new sharp cutter, and everything's prepped, ready to go. How do we move and handle Origin to get the best quality outcome? So we'll dig into that now. At its core, Origin is a hand tool. So it responds well to smooth linear motion and will deteriorate, the cut quality will deteriorate with erratic motion. So one way to think of it, if you're not familiar with power tools like a hand router, is like driving or motorcycling. If you put in erratic input into the steering wheel or the brake, you're going to get unpredictable outcomes. But if you plan in advance and prepare for your turns and do slow, smooth, consistent inputs, you'll get clean outcomes. Our goal here is to prioritize smooth linear motion. So we're going to move along and try to keep the dot centered on that line. But if we do drift to the side slowly, don't ever feel the need to lunge back to compensate. Let Origin help you. It can move anywhere inside that circle, the corrective circle. So then we just need to keep it coaxing along at a nice, smooth, linear feed rate. So it's better to drift slowly off and then come back slowly than to suddenly realize you need to compensate for something and move dramatically, especially across the cut line. So I'll show you what I mean by that. If I'm moving and drifting to the side, we'll see Origin respond just fine. Whereas if I do this, it's not apparent here, but it's less able to recover. So don't move to the edge and think, oh no, I've got to resolve this and then move across. Just gradually let Origin take care of the drift. Like I can actually move moderately fast and slow along the line, but my cut quality will deteriorate as I start doing this across the line. And the same applies to rotating. Even though you feel like you're rotating around the cutter, often it can end up moving quite a lot as you rotate. So try to plan where the tape is and plan your motions in advance so that you move Origin and just gradually compensate as you move. So as we move, keep an eye on the tape health meter up in the corner there. So if I move this way, rotating away, I'm starting to see less and less tape. At this point, I want to start responding by gradually moving the opposite direction. If I wait to get a low, this warning, there's not much time to respond, and a lot of people then abruptly try to do this, like rotating around. And that's going to get you a very bad outcome. So when we talk about planning, all we're really saying is so I'll start cutting again, I'm air cutting. As I start moving, as I start to get an indication that I'm running low on tape, instead of waiting to get the pink warning, just gradually move, tilt the other way until I can see tape again and everything's fine. That way, it's always a smooth linear motion and nothing is abrupt or jarring or anything that would overwhelm Origin's ability to correct for us. Okay, so we've talked about what we're trying to do here. Now we're going to look at how we achieve that. The first and foremost thing is if we hold Origin down moderately firmly, we get a consistent cut depth. We're less likely to have Origin wobble and shake. We can damp a lot of that vibration and just mechanical motion we're going to experience during the cut. So you have to keep a modest, firm hold on Origin, and then we can use our fingers or the sort of side of our palm to just rest on the surface. And much like you would use if you were using a mouse, you can sort of walk around and just sort of keep track of where you are so that you can keep a clean, smooth, linear feed rate happening. And then you'll listen to the cutter. It will be making a noise you'll familiarize yourself with an appropriate kind of chip loading. So in this demonstration, we're performing a litmus test to confirm that origin is set up correctly, workspace and lighting and everything's prepared appropriately. And we're going to be cutting 1/8 of an inch deep with a 1/4 inch cutter. So this is just to look at a raw cut to make sure everything's cutting smoothly. If you're actually in the field trying to pursue good outcomes and the cleanest, most dimensionally accurate cuts, you would usually do roughing passes followed by a finishing pass. So we have other videos explaining that. We'll link to that down below. So here's another issue with cut quality or potential pitfall. Make sure that your collet is clean and then tightened appropriately. It doesn't need to be crazy tight. And then another one that can catch you out is just remembering to tension or to torque the spindle clamp. So you definitely get bad quality cuts if you forget to do that up. Now, we know the material we're using. This has an impact on cut quality. So I'm in Baltic birch here on the back face. This is relatively consistent density, so I'm going to be able to get much easier high quality cuts with this than, say, someone using hardwoods or lower quality ply with variable densities throughout, and even openings and little holes inside the laminations. So you may have to cut a shallower depth or have a bigger offset for your roughing pass if you're cutting into denser or more unpredictable materials. I've set my spindle velocity between 5 and 6. I know I can move at a moderately consistent pace, so I'm not going to burn my bit. I could go up to 6 if I felt like it. But if it's set for a very low speed, if you were cutting plastics or something else previously, if you're down in the 3s or less, that will introduce a lot of variation and cut quality deterioration. So I'm between 5 and 6 there. So last step before cutting is a quick touch-off. We've got plenty of tape, so this should be pretty straightforward. We'll just set this to 1/8 and perform a cut. Sand a little bit of fuzz off here. So that's just a byproduct of using an up cutter versus a compression bed or something. But that right there is a very clean 5-inch cut. That's origin operating as expected.